Today we are going to talk about how to take those trig functions that you learned in the last lesson and use them to solve for sides and angles in right triangles. So we're going to jump right into examples. So in our first example, I'm going to have a right triangle. So I'll mark my right angle in there. And then we're going to know that this bottom side is 15. We're going to have an angle measurement of 27 degrees. And what we want to find is how long is that slant side or the ramp or the hypotenuse here. And so to do this, what we're going to do is label our triangle according to our focus angle. You may never focus on the 90. Okay? That will not work because 90 has an opposite that is the hypotenuse. So if we try to label opposite, adjacent, and hypotenuse, the same side has two jobs, and that can't happen. So don't choose your 90. So I'm going to choose 27. So then when I label this triangle, X is across from the right angle. That means X is our hypotenuse side. And 15 is right next to that 27. That means 15 is our adjacent side. The opposite side is blank, and we honestly just don't even really care because it's not labeled with a number, and we're not asked to find what it is, so I'm not even going to label it as being the opposite side. What we need to know now is which of the three trig functions that we learned will use adjacent and hypotenuse. So there were a couple of different memory tricks that I talked about for that. One of them we said was SOHCAHTOA, or Oscar had a heap of apples, or I said come up with your own sentence. So in this problem, if I have an adjacent and a hypotenuse, that's the AH, so that's the ca part, and the C is for cosine. So what we're going to do is set up a cosine equation. Every trig equation is going to have exactly the same format. For every single problem in this lesson, you're going to write trig, angle, that's the symbol for angle, equals side over side. We're going to fill in those blanks with what parts we know. So in this problem, the trig function we want to use is going to be cosine. So we're going to fill in trig with cosine. The angle we chose, 27, equals cosine is adjacent. The adjacent is 15, and adjacent over hypotenuse, the hypotenuse is x. So we filled in each space here. We only have one unknown, x, and that means we can solve it. If we have more than one thing unknown, then that means we can't solve the equation. So to solve this for x, it's going to take a couple steps of algebra. What we're going to do first is multiply both sides by x. Because x is on the bottom of the fraction, that'll cancel out the x over there. But it didn't really get x alone. Now our equation just has x on the other side, and it says x times the cosine of 27 equals 15. Now I wrote the x in the front on purpose. I find if students put it next to the 27, they'll accidentally get it like inside of the cosine. It is not with that 27. That 27 is stuck inside of that cosine cage. The x is outside. So I like to put my x in the front of it so that I make sure that that's staying separate. And now I want to get it alone. And since it's x times something, we undo times by dividing. So I'm going to divide both sides by cosine 27. That will cancel off over there then. And that leaves me with x equals, and now I need to know what 15 divided by cosine of 27 is. So I'm going to go ahead and type it into my calculator here, and then I'm actually going to pull up a calculator and show you exactly what you need to do to type this in, but just so we can get our answer, and then I'll go back and show you how to type it in. 15 divided by cosine of 27, and I got 16.8. 16.8 is our answer here. 16.8 is how long that x side of the triangle would be. It looks like my writing froze there. At 16, it's 16.8. I'm not sure if the writing's going to catch up. I hope so. But we'll go ahead and flip over to a calculator so I can show you how to type that in. So on here, I'm going to go ahead and turn it on. And then the first thing you need to do, and you only need to do this once, but it's very important that you do this, go into your mode and see on this third line down on mine, it might be the fourth line down on yours, depending on what kind of calculator you have, are the words radian and degree. We actually need the word degree selected. So I'm going to come down over here, over onto the word degree, and I'm going to press enter so that that word degree is selected. And there's two different ways to measure angles, radians and degrees, just like we can measure length with inches or centimeters, or we can measure temperature with Fahrenheit or Celsius. There's different ways to measure, two different ways to measure angles, radians and degrees. We're working in degrees, so we want that. Okay, after you make sure that's set, then you're good to go on the problems. And so in this one, what I wanted to type in was 15 divided by, that cosine button's like almost right in the middle of our calculator there, cosine, and it was cosine 27. I'm going to close off those parentheses and hit enter, and that's where I got my 16.8 as my answer. Okay. All right. Oh, and the 0.8 did catch up there. That's good news, so that now when I go on to my next example, hopefully it'll be working and not too laggy. All right, so next example, we'll do another one solving for a side here. Solving for a side. I'm going to say this time, I know the bottom is 4, but I want to find that other side. And my angle, I'm going to say over here is 32. Okay. So for this problem, I'm going to choose my focus angle. I'm going to go ahead and choose that 32. I cannot choose the 90. I could choose that other angle if I wanted to. Remember that a triangle's angles add up to 180 degrees, so I could subtract 180 minus 90, the right angle, minus 32, and that would tell me what that other angle was, but I might as well just use the one that I'm given. So I'm going to choose that 32 as my focus angle. This blank side, that would be the hypotenuse, but we don't really care about it because we don't need it. Opposite of the 32, we're going to call opposite, that's the x, that's straight across from the 32. And right next to the 32, that is our adjacent. So in this problem, we need to choose the trig function that utilizes opposite and adjacent. So when we look at SOHCAHTOA, opposite and adjacent, this time we're going to use the TOA. We're going to use the tangent. So when we set up that trig equation, trig is tangent. The angle is 32 equals, for tangent, the sides are opposite, which is x, over adjacent, which is 4. So now our equation is all set up, that exact same format every single time. Now to solve this, I'm going to go ahead and I'm going to multiply both sides by 4 because 4 is on the bottom of that fraction. That'll clear that off. And just like last time, I put that 4 out front because it's not 4 times 32. It's 4 times the tangent of 32. It's an order of operations thing. So in this problem, it actually did get the x alone. The x is totally alone over there on that right-hand side now. So now on my calculator, I can type in 4 tangent of 32, and I got an answer of 2.5. And in the calculator, just to show you, I would type in 4 tangent 32 and close those out, and then we get that answer of 2.5. Okay, so that's how you solve for a side that is missing. Next, we're going to look at how to solve for an angle that is missing. So to solve for an angle that is missing, I'm going to say we're missing that top angle. And we know these two sides. Okay, so first step, choose our focus angle. Well, we might as well focus on that x because that's what we want to find. So let's focus on it, right? We can't focus on the 90. We might as well focus on the thing that we want to find. So we're going to focus on x. We're going to label the sides of the triangle. 15 is across from the right angle. That makes it the hypotenuse. And 12 is opposite of the x. So that's our opposite side. So when we think about SOHCAHTOA, or Oscar had a heap of apples, or whatever other sentence you've come up with, we want to choose opposite and hypotenuse. That is going to be our sine function. So we're going to set up that same format. Trig of angle is side over side. And in this problem, our trig is sine. Our angle is x. And then sine is opposite. That's 12 over hypotenuse. That's 15. So now we need to get x alone. You cannot divide by sine, okay? Because this doesn't say sine times x. It says sine of x. Sine is a function, much like a square root or a log, some other function that we've learned. We cannot divide by it. And I mean, I can show you on the calculator if we try to do 12 over 15 divided by sine. Nope, the calculator doesn't like that. Unless we say, oh, maybe it's because I didn't like, oh, I gotta close the parentheses, right? So we'll close the parentheses, and nope, it doesn't like that. You can't divide by just the word sine, because sine is not times x, sine is being applied to the x. So what we have to do is peel that sine off, and everything in math has an undo. So, like I said, a square root, we would square. A logarithm that we learned about earlier this year, logarithms and exponentials undo each other. That's how we do that. Adding, subtracting, multiplying, dividing, right? Everything has an undo. The undo for trig is really fancy. It's called inverse trig. That's it, inverse trig. So the way we write it is the same trig function name, but with that little -1 symbol that we learned earlier this year means inverse. And I'm going to apply that inverse sign to the sign. And what that does is it cancels it off. It's like putting on your socks and then taking off your socks, right? It's doing it, it's undoing it. It's squaring, it's square rooting. So it cancels it out and will leave just the x. But I can't just do it on the one side. In algebra, whatever we do, we have to do to both sides. So over here, I also need to apply an inverse sign to this fraction. So that's a sign with a little -1 on it. And then I'm going to type that in my calculator, and I'll go over to the calculator and we'll see what that is. So I'll clear that out because that wasn't the right way to do it. That inverse sign we can see right here. It's that yellow sign with a -1. To get that, I'm going to press second and then my sign. And that was 12 over 15. And I close that up, and that gives me 53. So our angle in this problem was 53 degrees, approximately. Pay attention on Khan Academy for your rounding instructions. One more example. Finding an angle. So let's say, here's our triangle. I drew them all the same way. I probably should have turned them around upside down and stuff like that, but oh well, here's our triangle the same way. X is where I'm going to focus because that's what I want to find. So I'm going to label my sides. Hypotenuse across from that right angle, but we don't really care what the hypotenuse is because it's not labeled in this problem. X is across from or opposite of the 2, and X is right next to or adjacent to the 7. So opposite and adjacent. In this problem, we're going to use tangent, opposite, adjacent, so TOA. So my trig equation, trig is tangent. I started to just write trig. Tangent. Our angle is x. Our sides for tangent are opposite, which is 2, over adjacent, which is 7. To peel that tangent off of the x, I am going to apply an inverse tangent. But whatever I do to one side, I must do to both. Inverse tangent cancels regular tangent, just like putting on your socks and taking them off. But on the other side, we need to apply that inverse tangent to the fraction of 2 over 7. So then I can go to my calculator and type that in. I press second in tangent to bring up that inverse tangent, 2 over 7. And I close up this parentheses and I press enter, and I find that angle is about 16 degrees in that problem then, depending on how we need to round. So on your calculator, again, before you start working, make sure in your mode that you're on degree. After that, the buttons we need here are sine, cosine, and tangent right in the middle if we're solving for a side, If we're solving for an angle and we need to peel those off, we're going to press second and then the sine, cosine, or tangent button. Hit me up with your questions as you're working through your problems and let me know how I can help. See you again soon.